Good morning, everyone. Welcome to 1320, number 9, I think. Today I'm going to talk over, just go over the syllabus, and then some information about our Canvas page, and then if we have time, we'll start the 6.4, our very first section. So let me share our screen first. So my name is Dihan Dai. I would prefer you just call me my first name because the last name sounds like Dai. And this is my email address. You can contact me if you have any questions, or you can just send me a Canvas message. And of course, this is my personal Zoom link. And then the office hour is still TBD, and I'm still trying to get in touch with our TA. In the textbook for this class, it's the same as the Engineering Cal 1. It's the Calculus Concepts and Context by James Stewart. And this there is an inclusive textbook on our Canvas page. If you go to our Canvas page and click the bookshelf on the left, then you'll find the textbook there. And right, and if you want more information about this textbook, you can just click this link. And this course is fully online. That means we'll meet here every morning at the same time, except Thursday morning. Thursday morning is for the labs. Then there's some course information and some prerequisites and a course description. So basically we have, I think we have 3 main topics this semester, except the chapter 6, all the sections in chapter 6 are more like the continuation of the last semester. I think it's like something that's supposed to be in Engineering Cal 1, but we don't have that much time to go over it. And after that, there are 3 main topics. One of them is the series, which we will spend the first 6 weeks on it. And the second topic is the vector calculus. Well, the vectors in the space. And in that topic, we will extend all the results on the plan to a 3-dimensional space. And then after that, it's some multivariate calculus, which means we won't have one single input. We'll have 2 or more inputs, and we'll study the calculus of those functions. And then the grading. The homework assignment is 15%. There will be roughly 20 to 30 questions in every homework assignment. And it's due every Friday at midnight, except this week and the exam week. There won't be any due date on the exam weeks. And then, of course, the first homework will have more questions, just because we will have about 1.5 week workload. We'll just have more topics before the first homework due, since there's no homework due on the first week. And then for the homework, the grader will pick, the grader will pick 2 questions to grade for correctness, and each one of them is worth 5 points. And then the other 5 points is from the completion of the homework. And right, and then there will be quizzes on every Tuesday, except again the exam weeks. There won't be any quizzes on the exam week. the quiz will be Canvas quizzes. If you go to our Canvas page, then just click the assignments, yeah, well, I think there is only one a sample quiz there. So if you click that, you see the quiz are just some multiple choice questions. And the calculation, I think most of the quizzes I had last semester are elementary, and they are just calculations. I may add some conceptual questions this semester. And right, and then after that is the labs. The labs is due on every Thursday, and I don't have many details at the moment. I will have to discuss with our TA, but it'll be just, I think it would just be similar to the lab questions you had before, except for the online lab, you will only need to do 2 to 3 questions. It's not as long as the actual the in-person lab. And then after that, there will be midterms exams. We'll have 2 midterms exams, one on February the 26th, and the other one is on April the 9th. And I haven't decided how to conduct these midterm exams. I had a full 60 minutes exam last semester, and I was advised to have, instead of a full 60 minutes, I was advised to have 2 separate, like a shorter period of exam, like 2 30 minutes exam. But I haven't decided that yet. I will let you know once I decided. And then there will be final. So the official schedule for the final exam is April 30th. But it's not it's just not finalized, the dates, and I have to figure out what kind of exam I wanted to do. I want to do for the final. Last semester I did a full 2 hour, and the exam contains all the sections of this class, and I may do something different this semester. And then right, all the assignments, all the homework assignments and all the homework assignments, lab assignments, midterm and final will be submitted via the Gradescope. You can find the entry of the submission once you click the corresponding assignments on the Canvas page. And of course, there's no assignments on Canvas right now, so you will see when I assign the first assignment. And right, this grayscale is just a normal grayscale. And then there is some additional resource. There's an online tutor lab from the math department, which is totally free. And I also attached the link here. So if you go to, let me start a student wheel. So if you go to our homepage of the Canvas, then so there is a link here, which is called Virtual Math Tutoring Center. And if you click on it and open the tutoring center in the new window, you can find the Math Tutoring Center. It's just similar to the one that's on the basement of the math department, but now it's totally on virtual. It's totally online. And then there's, of course, some lecture videos on on calculus 1 to calculus 3. And we have the topics of this, a lot of topics of this class can also occur in the calculus class. So you can, if you want some additional resources, this can be a good resource. Then there's some expected learning outcomes. So these are basically just the topic we'll cover this semester. Then right after that, there are some important dates. There will be a deadline, a drop deadline, which is 2 weeks from now, or just next Friday. And the President's Day is on February 15th. The last day to withdraw is March 12th. Also a Friday, the first midterm is February 26th. And there's an official non-instructional day, which is March 5th. First week of the March. And there will be a reading week, which is the same week as our spring break. And on that particular week, we won't have any assignments. So basically it's a week that, well, you can recharge yourself and then just come back after that week. And there'll be another non-instructional day on April the 5th, the first week of April. And after that, it's midterm and final exam. Then,
excuse me, can I ask a quick question about those dates?
Sure.
That reading week, is that specifically for this class, or is that a university-wide thing?
I think it's recommended for faculty or for instructor, but it's not. I think it's just for this class.
Okay, thank you.
You have to ask your the class of the instructors of your other classes. And right after that, there are just a bunch of statements, official statements. And I believe you have seen this a lot. So I'm not going to go through over these. Any questions on this syllabus? So this reading week was not on the original syllabus. I updated, so you can find it in the new one.
I have a question.
Sure.
So are the quizzes going to be proctored in class on Tuesday, or they're just kind of like a due date at like midnight that you can get them done?
It's just
whenever?
due there on midnight.
All right.
So it's just Canvas page, and you just need to click the quizzes on Canvas. You can find the quiz there. And you click it. You do it before the midnight. You have two attempts and at most 15 minutes to finish the quiz.
And I also have a question.
Sure.
On the homework section, it says homework will only be accepted in class, no electronic copies. What does that mean?
Right. I should delete that. So it will be just, so I can show you one of the past assignments. You will submit your homework via Canvas electronically. There will be a Grayscope entrance. For example, if I click this, yeah, I believe it's not here. But and then you can find this, and then you can find a Grayscope entrance. Once I create the same assignments, a link between the Grayscope and Canvas, and then you can submit your homework once you finish it from here.
Got it.
Any other questions? So for Canvas, since this is an online class, so most of the resources, I think all of the resources for this class, you can find all of the resources for this class on Canvas. So under the course essential tabs, you can find a course calendar, which is basically a tentative schedule for this class. And you should check this site. We may move faster than this calendar, since there is one last week in the spring, I think. At least that's what I was told. But we'll be able to finish them. It's not. There are actually not a lot of topics here. And then there is also a textbook option, which is, so there is an inclusive textbook on Canvas for everyone. And if you want to opt out of this, this program, you can find some alternative here. And right, I believe there is a due date for this opt-outs, but I don't remember which day is it. I have to check it later. But if you choose to stay in this program, and if you just click the bookshelf, you'll find our textbook. And our lectures will mostly follow this textbook. Then after that, there's an updated syllabus here. And these modes are not on the Canvas yet. I will post them once we are close to some of the exam. And right. Yeah, and then there are some supplementary materials here. So the first one is the first file here. This full course knowledge checklist are just some additional practice for the topics we are going to cover this semester. There is an extensive list of topics here, and there is also some concepts or more like a summary of the formula we will learn this semester. And then if you need more practice or you need to review some materials before the exams, you can use this file. It's called a full course knowledge checklist and practice. And then there's also some integral practice. So if you want to practice your integral, these are just single variable integral. If you want to practice your integral skill, you can use this file. But this is the full knowledge checklist. So you need to locate the integral, which is about, yeah, it's way below. It's probably the end of this file. Right, something like between this. I think if you download this, you can find file contents there. And if you want to practice your integral skill, you can take advantage of this file. And then there is also some reference sheets. This is for midterm 2, which is not your concern right now. And these two files are for the reference sheets for our first midterm or for the whole series chapter. You can just click on it. You'll find a bunch of tests there, some decision tree, and to help you to find the best test for a given series. And there's also some practice example here. And in the study of this section, the series section, if you forget some of the series tests, this is a good good file for you to quickly locate the best test or some good test for a given problem. And then, right, these are just these tests, and there are also some links here. The first one, I believe, you already have some have your preferable PDF or like pictures to PDF file tools. And if you haven't found one, you can use this website, which can convert a lot of which allow you to manipulate the PDF. Like, for example, you want to merge some files, or you want to, what is it? Yeah, if you want to convert a JPG file to PDF file. If you haven't have a PDF tool, you can use this website. Otherwise, this. I just put that for in case you need it. And right, this is the link for the online videos of the departments. You can see there's Cal 1, Cal 2, and Cal 3 here. I think for this class, you probably need some videos from, if you want to watch the videos, the Cal 2 and Cal 3 videos will be useful. But Cal 2 and Cal 3 Cal 2 and Cal 3 classes cover more details than our class. And then the last one is just the math tutoring center I mentioned before. And right, there's announcement tab. You can check the announcements. If I put one, I will try to minimize the announcements I put this semester. That means I will only put announcements on, I will only post important announcements. And then, right, there's assignment tab. You can find all assignments once the assignments are posted. Right. Then, right, there's a discussion tab on Canvas. So I posted one of them here, just for general Q&A in case you forget some of the policy. You can chat the syllabus, or you can just ask questions here. There's also a summary of some important parts from the syllabus here. Then, right. There's one more tab I want to go through here is the file tab. Throughout the semester, you can find all the files, all the resources under this file tabs. The final and midterm will only released when we will have the exam on the exam days. And yeah, these folders will be released once I put something in there. And right, there's lecture videos. So all of our videos this semester will be recorded, and I will just post the videos to this folder. So if you miss a lecture and you want to watch what we go over or what we cover on that day, you can just go to the lecture video folders and check the videos there. Okay. And of course, there's no requirements on the attendance for the class. Any questions? any general questions on the class?
Yeah, I have a question.
Sure.
Do we have a lab this Thursday?
Yes, we will.
Okay, thanks.
So let's just jump to our first section, the arc length. Yes. Excuse me for a moment. Okay, I'm back. So our very first section, it's the arc length section. In this section, we will try to figure out how to calculate the length of an arc while on the plan. So suppose you have an arc, and our goal in this section is to figure out the length of this arc. So the idea is similar to the arc length. The idea of finding an arc length is similar to finding the area under a curve. What we will do here is to first just to part this arc into a bunch of sub-arc. So we'll just part this arc into a lot of pieces, small pieces, pi plus 1, then so on. Just like what we did for the integral, we divide the a interval into a bunch of subintervals. And the idea is that for each subarc, you can approximately, like the arc length from pi to pi plus 1. This can be approximated by the segments between pi and pi plus 1. So if we zoom in this part, originally the arc was like this, pi plus 1. And the idea is that when these subarcs are small enough, we can approximate the arc length from pi to pi plus 1 by the length of the segments from pi to pi plus 1. So like this. So we claim that if the subarc is short enough, then the red dashed line is approximately the same as the black curve or the black arc. And then in order to calculate this the segments, you see we can use the Pythagorean identity. This from here to here, we call the increments in x, delta xi, and the increments in y, delta yi. Then this guy, pi, the segments from pi to pi plus 1, is simply just the square roots of delta xi squared plus delta yi squared. So now, if we know the expression or the parametric equation, for this curve. So suppose the curve is given by this parametric equation. X is equal to f of t. Y is equal to f of t. Then delta x I then this delta xi divided by delta t is approximately f of ti, f prime of ti. Because the increments in x with respect to t is approximately equal to the derivative at that point. And delta yi divided by delta t is approximately g. This should be g of t, my bad. And this guy is approximately g prime of t. Yeah, this is a usual trick for the calculus. And then once we have that, we can compute this. We can replace this expression in terms of ti and get f prime ti squared plus g prime ti squared. Then there is a delta t outside. So originally the delta t is from the inside, because from here you get delta xi is equal to, from this expression, you get delta xi is equal to f prime of xi times delta t. And if you square it, you get f prime of ti squared multiplied by delta t squared. And similar thing is, and it's similar for the second term. And then there will be a delta t squared. And if you just factor out that delta t squared and take the square roots, you get a delta t here. And this is just the eyepiece of this arc. So the whole arc, the length of the whole arc is approximately the sum of square roots of f prime ti square plus g prime ti square times delta t. And then this I is from 0 to n minus 1. Because this arc starts from P0. So the first piece will be P0 to P1, and then the last piece will be Pn minus 1 to Pn. And then we know that this is just an approximation of the arc length. In order to get the accurate arc length, we need to let n goes to infinity. And then when n goes to infinity, this these interval of ti minus ti plus 1, this will become infinite small. And this whole sum, this infinite sum, becomes an integral. Right. Which means the sum notation becomes a integral notation. The ti, you will replace the ti with t squared plus g prime t squared. And then delta t becomes dt. And the bounds is given by the bounds of t. So let's assume it's equal to, the lower bound for t is equal to a, and the upper bound for t is equal to b. And P0 Pn will be equal to this integral here A represents f of, right, so when t is equal to A, the point is P0. When t is equal to B, point is Pn. So the starting points and the ending points of the arc. And this is the very first arc length formula. And this is the arc length formula for parametric curve. If the curve is given by x is equal to f of t and y is equal to g of t, you can use this formula. And we know there are different ways to represent an arc or a curve. For example, if the curve is given by y is equal to f of x, then this thing becomes, let's call this formula 1. Then this formula becomes the integral from a to b. So also assume the bonds for x are a and b. This will be equal to 1 plus dy dx squared dx, and is equal to the integral of 1 plus f prime of x squared dx. You can actually derive this formula from the parametric curve. You just need to consider the parametric curve x is equal to t and y is equal to f of t. So then the first term, f prime of t, which is from the parametric curve, which means you need to calculate the derivative of x with respect to t. That gives you 1. And then the derivative of y with respect to x, since x is equal to t, is just f prime of x. So this formula is actually can actually be derived from the first formula. And then there's one more way to represent a curve. X is equal to f of y. Now let's assume y is from A to B. Then the arc length, L, is equal to the integral from A to B of square roots of, now it's dx dy, so it will be f prime of y squared plus 1 dy. And again, you can derive this formula from the parametric curve. You just need to let x is equal to f of y and y is equal to f of t and y is equal to t. Then apply formula 1, the first formula from parametric curve, you can recover this formula. There are more details on the derivation of these formulas on our textbook. If you are interested in it, you can just go over our textbook. But the basic idea is just use the Pythagorean identity and you take a limit, you can get the formula. So let's try an example on this, on these formulas. Suppose we want to find the length of the arc of the curve given by a parametric equation. X is equal to t squared, y is equal to t cubed. That lies between the points 1, 1 and 4, 8. So this is a parametric equation, and apparently we need to use the first formula. And we need to use the first formula. L is equal to the integral from a to b of square roots of f prime of t squared plus g prime of t squared dt. And it's very straightforward. You just need to, so in this case, x is equal to t squared, which is our f of t. And y is equal to t cubed, which is our g of t. So f prime of t is just equal to 2t squared. And g prime of t is t cubed, so it's 3t squared squared dt. And is equal to the integral from a to b of square roots of 4t squared plus 9t to the 4 dt. The question is, how can we find the bonds A and B? So we know this this curve starts at 1, 1. We want to find the curve, the length of the curve between the points 1, 1, which we can call it our starting points or initial points. And there's a terminal points. There's only one point here, which is 4, 8. And we are given these 2 points. The question is, how can we find the bonds for t? So we know these 2 points are on this parametric curve. So that means x, the first one, for the initial points, we have t squared is equal to 1 because it's on the parametric curve, so it must satisfy this equation. So you have a t squared is equal to 1 and t cubed is also equal to 1. And the only possible t that satisfies both is equal to is when t is equal to 1. And from here you get one of the bound for t, or the lower bound for t. And for the terminal points, we have a similar equation. So again, the terminal points is also on the curve. So it must also satisfy this parametric equation, which means there exists a t such that t squared is equal to 4. And at the same time, t cubed is equal to 8. And the only possible t here is when t is equal to 2. You can see it by just dividing the first equation, by just dividing the second equation by the first equation. And from this, based on these calculations here, you can get this integral is actually from 1 to 2 of square roots of 4t squared plus 9t to the 4 dt. And what's left to do here is just to solve this integral. Because t is a number between 1 and 2, so it's a positive number. So we can factor out the t squared. We can first factor out the t squared from the insides of the square roots. You get t squared. You get square roots of t squared times 4 plus 9t squared dt. And because t is a positive number, because t is between 1 and 2, so it's a positive number. So we can factor out that t and get and simplify or transform this integral into this integral. The integration of t times square root of 4 plus 9t square from 1 to 2. And then we can use the u substitution because there is a 4 plus t square inside the square root function, and there's a t dt outside. And that usually indicates you have to use u substitution, and the u should be a function of t squared. And in this case here, it's very convenient to just let u is equal to 4 plus 9t squared. So then du will be equal to 18t dt. Then and then from here, if you divide both sides by 18, you get 118t dt, 118 du is equal to t dt. I divided both sides by 18 here because the term that occurs in this integral is t dt, not 18 times t dt. So now we can do the u substitution. We first change the upper bound and lower bound from t to u. So since t is from 1 to 2, so the lower bounds for u will be 4 plus 9, which is 13, to 4 plus 36, which will be 40, square roots of u. And t dt is equal to 1/18 du. And then after that, that's just 1/18 of 2/3 times u to the 2/3, 3/2. U is from 13 to 40. You can use an integral formula here. The square root of u is just u to the 1/2. So the integral of it is equal to 3/2 u to the 2/3 times u to the 3/2. And because the bonds are from 13 to 40, so it's just this. And once you plug in the number here, you get this just equal to 1/18 times 2/3 times 40 to the 3/2 minus 13 to the 3/2, and is equal to 1/27 times 14 to the 3/2 minus 40 to the 3/2 minus 13 to the 3/2. And I am happy with this final answer, but if you want to keep simplify it, or you want to plug this, if you want to input this number in your calculator to get a decimal number, that's okay.
I have a question really quick.
Sure.
How did you change the bounds from 1 to 2 to 13 to 40?
So the original bounds for t is from 1 to 2.
Okay.
And for the lower bound, you just need to plug in t to this u. So you get 4 plus 9 times 1 square. And you do the same thing for the upper bound of t. You plug in t is equal to 2 to this u, you get the upper bound for t.
Okay, cool. Thank you.
Any other questions? Okay, I will meet you tomorrow. Here? Yep.